This is Algebra 1, Semester 2. This is the second unit, 2 variable data. And this is the 6th lesson, Exponential Data Distribution Practice. This is from creatormath.com. It's under the Algebra tab, actually, because this is a Statistics Light section unit in Algebra 1, Semester 2, to prep students for more rigorous statistics work later. Copy the following problems into your composition book, and these you can probably copy, but check the notes. They might be repeats. You do not have to repeat graphics if they're in the notes already, and that's what it says here. According to the table of contents with the notes for those pages. Don't forget the notes. They explain most of the background data of what this is about from creatormath.com under the Algebra tab. So this one says, given the following exponential graph of data, use Desmos.com to identify the function. I've got a printout from Desmos right here. That's where these are printed out from, this graph right here. I want you as a student to go to Desmos.com and type in these functions down here. Y equals x squared, y equals x to the power negative, y equals 2 to the x, y equals 2 to the negative x, y equals negative 2 to the x, y equals negative 2 to the negative x. These four situations play with the exponential curve and give you sort of an increasing idea of how this works. So they want us to match this graph with which function it is. This one's the easiest and simplest. It's an exponential growth curve that starts here, cruises up, and goes through this point here, which if I had done it right would be 1. And it is. You can see it 1, 2, 3, 4, 5. So it's right here at a point crossing through. This is the classic exponential, the base exponential function of y equals 2 to the x power. This is very relevant right now. This is the graph of the spread of a virus. So, the way a virus works is one person gets sick and gets 2 others sick. Those 2 get 2 others each sick. And those people get 2 each sick. And all of a sudden, everybody starts getting sick so quickly that the entire world is sick. And unfortunately, we are living an example of this kind of curve. And if you're watching the news these days, you'll see this curve. You'll see, hey, we only had so many cases here, right? And then all of a sudden they doubled, and then they doubled again, and then they didn't stop. They just went straight up. The only thing that would limit the spread of a virus would be something like vaccinations, right? A vaccine and vaccinations can start to limit the virus. Wearing a mask, if that stops it from spreading, you can start to curtail this curve, and this curve can be made into other things, right? That's why early on they were talking about flattening the curve. This is an exponential curve. It is not flat. Anyway, you get some very good context for this that, I remember talking to students about the spread of virus, and I'm not sure they really knew what we were talking about. But now, I think most students know exactly what we're talking about. All right, let's look at how the exponential curve can be moved around. Exponential phenomenon can go different routes, like on this one. And again, you're typing these functions into Desmos.com down here, and you're seeing which one matches up, and then just select your answer based on that. It's really getting you to go practice using Desmos more than anything. Type it in exactly how you see it. You do have to type in y equals on Desmos to get this to graph. Okay, so what's happening here? The curve is coming down and flattening out and going to 0, right? It is still passing through 1. And this is a y equals 2 to the negative x. Right, so we had y equals 2 to the x this way. Write it like they write it, right? We may write it like this, 2 to the x power. This one over here is 2 to the minus x. Right, now guess what? They're going to run through 2 other options by now putting the negative on the base number. So here we have a graph that's falling off. This one's in the negative. Less used, but nonetheless part of the math realm. And so y equals negative 2x with this one. And then they're also going to put a negative on the x. We'll have a negative 2 and a negative x. And that's going to go the other way. going to come back like this. Less useful for us in terms of physical phenomenon of things that go into the negatives. Less useful for us, but still nonetheless applicable in many situations. And once you learn the other two that occur in physical phenomenon, it's nice to see the two math options right here. So this would be -2 to the -x. Right? So we had this one. We had y equaled -2 to the x, and this one is y equals -2 to the -x. Again, part of the whole point of this is to plug them into Desmos.com and to practice graphing and make sure you know how to use those. So don't miss that opportunity. And otherwise, you can find this under the Algebra tab on creatormath.com, and it is under the 2 variable data unit. And this one's lesson 6, exponential data distribution practice.